There's one more problem that I forgot to do in the previous section. I'll go ahead and do it here. Um, so if you want to prove that this is true, we can start here with the left-hand side. And notice that we're going to have sine x plus cosine x squared. This squared basically means that you have two of these guys. So you're going to have sine x plus cosine x, and then another sine x plus cosine x. So let's FOIL everything out. So the first guy is going to give me sine squared x. The next guy is going to give me plus sine x cosine x. The middle guy is going to give me sine x cosine x again. And then the last guy is going to give me plus cosine squared x. So notice that you're going to have sine squared x. I can put the cosine squared x in front of it so that I have all my square terms first. Notice that this guy and this guy is going to give me plus 2 sine x cosine x. And then finally, well, using the Pythagorean identity, we know that this guy is just equal to 1. So 1, and then plus, we just have this guy left over. 2 sine x cosine x. So that gives me the right-hand side. And now we're done. Okay, so this one you didn't really need to do an identity, but it is useful because sometimes you don't want to distribute this square to both of them. You want to go ahead and just make it into two different terms. Okay, so let's go now to the next section, which is going to be 9.2, which is sum and difference identities. So here there's more identities. We may do a little bit of verification, but there's other things that I feel are a little important. So usually when we look at functions, we know that functions can be rewritten as f of x, and the f of x is just basically the y value. But let's say you wanted to have f of x plus h, or f of x plus y, or whatever, you know. So one thing to know is that if you want to find f of x comma y, this is not equal to the function of x plus a function of y. It's not equal to that, okay? So here are some examples. So for example, this is a really common mistake, and let me write this in red. So this is not true. X plus y whole quantity squared doesn't mean that you are allowed to square each individual thing. It's not true. Okay. Instead, what you do is that you have to write both of them twice. And you can actually show that this is not true. Just plug in some numbers, plug in like 3 and 4. You'll see that that's not equal to. You'll see that if I put 3 plus 4 squared, this is not equal to 3 squared plus 4 squared. That's not correct. Okay. Same thing with natural logs. So we don't really work a lot with natural logs in this particular class, but when you get to pre-calc, or when you do a little bit more algebra, or maybe in some science classes, you'll see that this is not true. You can't just distribute the natural log to the x and the y. There's actually you actually can't do that. There's a different property that allows you to do that with natural logs. And same thing with trig functions. With trig functions, you can't do that as well. If you're adding two different angles here, then you can't just distribute the sine to both of them. That's not really quite what this is. Okay? So instead, what we're going to do is that we're going to try to prove to you that the sum or the difference between two different angles are not just a distribution. So the way that we're going to do it is we're going to use this guy. The cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So how the heck they come up with that? So let me go ahead and prove it to you. This proof is a little lengthy, so just bear with me. So we're going to start off by drawing a little circle. So we're going to draw a circle right here. So this is going to be our unit circle. So here's our unit circle. Okay. So what I'm going to do is I'm going to label 3 different angles. So the first angle that I'm going to do is, and I'm going to label this origin as O. It's going to be the angle that's formed from here to this particular point, and I'm going to call this Q. Now this angle, we're going to call it beta. Okay, so that's my beta. Now what we're going to do is I'm going to choose another angle. So let's choose this guy right here, and I'm going to call this P. So from here to here. So from the angle from the positive all the way to here. We're going to call that alpha. Okay, so that's the blue one. And then we're going to finally label one more angle. And this angle is going to be maybe around here. I'm going to call this A. And basically, the angle that this guy makes with the positive x-axis is going to be alpha minus beta. Okay, so I'm making it such so that I have these types of these angles. Okay, now there's a couple things that you can kind of see that basically I can kind of look at different distances. So to kind of just think about it as a triangle. So imagine that I was looking at the distance between P and Q. Okay, so I got this guy, and then I'm gonna have let's say the distance between A and right here, which is gonna be 1, 0. So you have this distance also. This is getting really messy, but okay, so you have this distance. So basically what you can see is that you have two different triangles here. So I'm going to label one yellow. So I'm going to label this one yellow. Okay. So you can see that you have this triangle right there. And then the other one, let me label it pink. You got this one right here. So just by looking at it, you can actually look because this guy, so let me put this guy, I don't know if you guys can really see it, but let me try to zoom in. So you can see that when I label this triangle or this angle from here to here, this was alpha minus beta, okay? So that means, how can I relate this pink triangle with this yellow triangle? Well, this guy, if I were to rotate this guy so that it's at P, these two triangles are basically the same. They're just basically rotated, because if this is alpha minus beta, that means that the leftover part should be the beta part, because if I add alpha minus beta, which is this guy, plus beta, I'm going to just get alpha. So these two triangles are basically the same, which means that the distances that I just drew, which is from A to, let me label this guy B, from A to B, and the distance from P to Q are basically the same. So distance from A to B and P to Q are the same. So what we're going to do is we're going to try to calculate what these distances are. So in order to find the distances, well, we got to label the point. So if this point corresponded with this angle beta, and this is a unit circle, well, this point should be cosine beta. Let me make it so that it's not too thick. Let me make it a little thinner. So this guy is going to be cosine beta, sine beta. So whatever that may be. This point right here, the P is just going to be, well, because the whole angle was alpha, this whole thing was alpha, that means this guy's going to be cosine alpha, sine alpha. And then finally, this last guy, which is right there, that guy is going to be, since this guy was alpha minus beta, this guy's going to be cosine alpha minus beta, sine alpha minus beta. Okay, so you're going to have these three different points. Okay, and now what we're going to do, we're going to use the distance formula. So basically, if you remember the formula for the distance, this is basically what it is. So the distance formula is basically the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to start off by looking at the distance from P to Q. Okay, so that's going to be this distance right here. So P and Q, so from this guy all the way to this guy. So we're looking at that distance. So what we're going to be using is these two different points. So the cosine alpha, cosine beta, sine beta. We know that this is x, and this is y and y. We can label them as x1, y1, and plug them into the formula. So what we're going to get is a square root. Oops, okay, square root. So the first thing is going to be cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. Okay, so now what we're going to do is we're going to FOIL all this out. So we're going to have a big fat mess. Let me write square root because it's going to be a long thing. Okay, so when I FOIL all this out, this is basically what I'm going to have. So I'm going to have cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. So basically this whole thing, this first part corresponds when I FOIL all that out, and then this other part corresponds when I FOIL all of this out. Okay? And now what I'm going to do is I'm going to combine a couple of the square terms, because then you'll see that I can use the Pythagorean identities again. So I can group these guys. We know that that guy and that guy, well, that's the Pythagorean identity. That's just going to give me a 1. You can also group this guy. So let me choose another one. So I'm going to group the cosine squared beta and the sine squared beta. That guy is also going to give me another 1. Okay, and all I'm left with is just these two guys. Okay, so I'm going to be left with negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Sine beta. Okay, so then let me just add this 1 plus 1. That gives me 2. So 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so that's what I get. And now you can kind of see that I really can't do anything else with this. So this is going to be basically the distance of this guy. All right, so now let's go ahead and just figure out the distance from A to B. Okay, so let's try to figure out what this distance is going to be from A all the way to B. Okay, so here, see how we have this x and y. We also have this other point x and y. So now let's figure out what the distance from A to B is going to be. So we're going to use the same exact formula. So now I'm going to use this cosine alpha, this x2, so that I can say this is x2, y2, x1, y1. So it's going to be cosine alpha minus beta minus 1, whole quantity squared, plus sine alpha minus beta minus 0, whole quantity squared. So when I FOIL this out, this guy is going to be another big mess. We're going to have cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1. And then this guy, the 0 is just going to go away. So all I'm doing is just squaring this guy. So it's just going to be plus sine squared alpha minus beta. Okay. All right. And now what I'm going to do is I can do the same thing that I did before. Look at these two guys. That's another Pythagorean identity. So that guy is just going to give me 1. All right. And then I just have this minus 2 cosine alpha minus beta. And then plus 1 extra. So 1 and 1 is going to give me 2. So square root of 2 minus 2 cosine alpha minus beta. All right. So now we found the distance of AB. Now we said that these two triangles are rotated from each other, so that means that the distances are going to be exactly the same. So that means that the distance from P to Q is going to be the distance from A to B. So what I'm going to do is these guys, I'm going to just equal them to each other. So the first one's going to be the square root of 2 minus 2 cosine alpha minus cosine beta minus 2 sine alpha sine beta is equal to the square root of 2 minus 2 cosine alpha minus beta. Notice that the square roots can kind of go away. So all I'm left with is just 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta is equal to 2 minus 2 cosine alpha minus beta. So a couple things should go away. So the 2's are going to go away. Okay, so I'm left with a negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta is equal to, now we're left with this negative 2 cosine alpha minus beta. So I can divide a -2 to all of the sides. So I'm left with, so on this side, I'm left with the cosine alpha minus beta. On the other side, I'm left with a positive cosine alpha, cosine beta. And then I have a positive sine alpha, sine beta. And this actually concludes the proof. Okay, because that is what we're trying to figure out. What exactly was cosine alpha minus cosine beta? And that was this guy. All right, so we finally proved it after much algebra. This is basically what it was. Now, I'm not expecting you guys to remember this, but I want to show you guys how we can come up with these formulas, where the formulas come from. I just don't want to tell you this is the formula. I want to be able, it's good to see where exactly these formulas come from. So let me go ahead and maximize this a little bit more. Okay, so there's other sum and difference formulas, and I wrote them right here. So even though we proved it, I'm not going to prove them for the other ones, or else we'll be here for a very long time. So here, kind of just a summary. Here, you can find the sine one very similarly to the way that we did it before, with the cosine alpha minus beta. So basically here, the way that you read this is that the cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. And then cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And then here, sine alpha plus beta equals sine alpha plus cosine alpha sine beta. Sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. Okay, so just make sure that you can kind of just get the formulas here. You don't have to memorize them in this class, at least. That doesn't mean that in other classes you might have to memorize them, but for this class you don't have to memorize them. But just know that what the formulas kind of look like and how you can kind of read them. So in the next video, we're going to go ahead and do a couple of examples.